Good afternoon, everyone. My name is Daniel Carteño. Today I'm going to talk about our research, which is titled Mechanicaloric Effect of Elastomers in an Automated Calorimeter. Well, a calorimeter is an instrument which allows us observe one specific caloric phenomena. This phenomena could be physical, chemical, or biological, and this time we are focused on mechanocaloric effect, which is defined as an effect which affects a thermodynamic system by mechanical action. The objectives of this work is based on Professor Takaske Matsuo from Osaka University and to build and automate a calorimeter to measure the mechanocaloric effect of polymer sheets of polydimethylsiloxane and ethylene propylene rubber. And how we did that? So we have to design based on Professor Takaske prototype to design another and automated calorimeter which allows us to obtain some thermodynamic properties as case-free energy, enthalpy of elongation, and entropy of elongation to characterize another kinds of elastomers by making a caloric effect. So we have to design this new structure of this new calorimeter, which is based on the prototype of Professor Takaske Matsuo, and this consists in a wooden mast with an aluminum box, which finally this wooden base that could serve to support the acrylic box and isolated the measurement area to obtain the adiabatic requirements of this instrument, because we need to measure temperature inside the sample, but only temperature changes and not with a medium. So we divided this by mechanical body and electronical body. The electronical body was controlled by microcontroller in by Arduino 2560 Mega, and we designed all the software by Arduino Software IDE to obtain an interface which allows us measure elongation and shrink of elastomers while they have an adiabatic linear deformation, to obtain these changes inside the sample and to get these changes versus time. As you can see in figure 1, we could uh, elongate and shrink two different materials, the polydimethylsiloxane and ethylene propylene rubber. And for the first case, we could observe that polydimethylsiloxane, while time is increasing, temperature is increasing under adiabatical linear deformation. But if we could notice at the end of every single adiabatical linear deformation, we could observe that polydimethylsiloxane not regress to its original parameters. This is very important in comparison with Professor Matsuo, because this is the tendency of the material to 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 observe that this is an dissipative phenomena, and which means that this kind of material is accumulating energy, thermal energy, before every single deformation. But on the other hand, as we could observe in EP, we could observe that in comparison with Professor Matsuo, we could obtain the characteristic graphic or plot of this material. which is that at the end of every single adiabatical linear deformation, the material regress in a way or in quasi uh, to its original conditions. Not this is very important because EP doesn't accumulate energy, and so that's why they regress to this material regress to its original conditions. So that's why we could obtain a calorimeter automated, which gave us information to characterize material. But if we compare again these two pairs, we could obtain another many points much than its predecessor, because with our sensors we could observe all or most of the points that material gets under adiabatical linear deformations, which is not observable by the its predecessor. That's why we could validate our new apparatus with lambda for PDMS for 5.3 and lambda from EP for 5.9. But at the end, we could obtain the elongation entropy of PDMS and EP, and we could observe that this tends to the same entropy. So that's why we, with this kind of apparatus, we could characterize obtaining one of their thermodynamic properties, some um, some properties of this material, but this could be applied to another kind of elastomers which are in sheet forms. That's why we concluded that an automated calorimeter based on Professor Matsuo prototype was built, and the instrument was validated using the reported area obtaining lambda from PDMS 5.3 and lambda from EP 5.9, and results showed that the instrument can repeat characteristic curves of the original data reported by Professor Matsuo. But these changes in the calorimeter, in the new calorimeter automated, could allow to study other type of polymeric materials, and the automated calorimeter can get with program conformational entropy related for every single rover. So thank you so much for your attention, and if you have any question or something, um, these are our contact.